Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to demonstrate another example related to finding the volume of a solid. So in this case, the solid is generated by revolving the region enclosed by these functions. So the first one is x is equal to 2 over y. Next, y is equal to 2 and y is equal to 6. So this is clearly the boundaries that you're looking for. And x is equal to 0 about the y-axis. Okay, so first of all, I think we need to visualize how does this look like. If it is comfortable to you, you can think of it as equal to xy is equal to 2 and therefore y is equal to 2 over x. And I'm sure that you'll be able to recognize the shape once you have expressed this equation in this manner. So so the shape is going to look like this. So the limit is the boundary is x equals to 0. So this is x is equal to 0. So that's the boundary. And so the expression here, the equation here, the graph can be sketched as such. So the graph can be sketched as such. We know that it's going to look like this, something like this. And then we have another boundaries to consider, which is y is equal to 2 and y is equal to 6. So the boundaries is this one. This is x equals to 0. Next, y is equal to 2 is probably this one. Okay, and next we have y is equal to 6, probably, I don't know, this one here. And so we are looking for this region. So we are looking for this region to consider. Okay, so this is the region that we are going to consider. Okay. Right, and this region here will be rotated, or it will be revolved about the y-axis. So it's going to revolve 360 degrees around this y-axis here. Okay, I'm really not good with this, but I'm gonna give it a try. So you can see that if this is the region that sorry, okay, let me try it once again. So you can see that if this is the region that you are interested with, and if it is rotated 360 degrees along the y-axis, then you know, you can imagine it going this way. Yep. So it's turning this side, yeah, and it can also come out like this. Oh, no. Oh man. Okay. Oh, it can also going this side. Okay, I'm just choosing the angle which I think it's easier to, you know, to sketch or draw. So you know, it can turn 360 degrees, and I just hope that you can imagine this turning 360 degrees, and so you will be able to get this kind of shape. Okay, the shape will be looking like this somehow. Oh. Okay, so it will be looking like this. not exactly like that. I know you get the idea. Just ignore my stupid drawing. So it's something like this. Yep. Something that looks like this. Okay. So now if you, okay, let me just sketch it on the graph. So based on the graph, so this is x, this is y, x and y. So what you have is you're going to have a solid that looks like this, and then something like that. It doesn't touch the x-axis actually. Okay, it doesn't touch the x-axis, so I'm going to set this a bit lower. This is x. Okay, so here is at 2 and this one is at 6. Okay, so it looks like this. Yeah, and I think you get the idea. Anyway, so next it says that this is sorry, it doesn't say anything, so it's just saying that it revolves around the y-axis. So you are required to find what is the volume of this solid, and you can see that this is the example where you have to integrate with respect to y, because in order to get a cross-sectional area of this, you are going to cut the solid here in with respect to y. So you're going to cut it through y in order to get the area. So you're going to cut it through y, and this is perpendicular to the y-axis. So when you cut it through y, you will get a surface that is going to look like this. Again, it is just a circle, and you know that the area of a circle is just equal to pi j squared. So if you cut it in this part, if you cut it on this part, then you will get an area here where the radius here is going to be depends on the value here. So this is, okay, recall that this is the function given. So this is the function, this is the function, and this is given by x is equal to 2 over y. So this is a function of x equals to 2 over y. So if you cut it on this part, you will see that the radius is going to be this value, which is you can read it from the x-axis here, which is going to be 2 over y. Now if you cut it in a different section, so for example you cut it on this part, then you can see that the radius here is going to be different. It is larger, and the value is given by, again, by this function. You can read it by finding what is x, and x is equal to 2 over y. So therefore the area is going to be equal to pi 2 over y, because the radius is different when you cut it through different parts. So this is 2 over y and square it. Okay, so that can be simplified as pi 4 over y squared. So this is the function that we are going to integrate with respect to y. Okay, so this is an example where you have a solid that is rotating about the y-axis, and so in order to find the volume, you have to integrate the area function with respect to y. Okay, so we're going to continue with that. So we have the limit is from, you can see this is the limit of y from 6 until 2. So the lower limit is 2, the upper limit is 6. Next we have 4 over y squared, and multiplied with pi, so sorry, pi 4 over y squared dy. Next, pi and 4 are constants, we can take it out. This is 6 and 2, 1 over y squared dy, and if you want you can write it in terms of y to the power of -2 dy, and if you integrate that you will get it equal to y -1, -1, 6 and 2. Okay, next that becomes 4 pi -1 over y, 6 and 2, and you can substitute these values accordingly, so that will be 4 pi -1 over 6 minus -1 over 2 is going to be +1 over 2. So this one is going to be equal to 4 pi over 3. Okay, I think that's all for now. Thank you very much for watching.